Good morning, students. Welcome you all for Next Generation Learning. Today, we are going to see the subject Physics, Class 9, Chapter number 8, Motion. And this chapter contains 6 topics. The first topic 8.1, Describing Motion. 8.2, Measuring the Rate of Motion. 8.3, Rate of Change of Velocity. 8.4, Graphical Representation of Motion. 8.5, Equations of Motion by Graphical Method. 8.6, Uniform Circular Motion. Today's topic 8.1, Describing Motion. Under this topic, we are going to see motion along a straight line, uniform motion and non-uniform motion. The first one, Introduction. In our day-to-day life, you know that some objects are in motion, some objects are in rest. How you say that the object are in motion and rest? According to time, we can describe the object are in motion and rest. According to time, the position of the object will change means then we can say that the object are in motion. According to time, the position of the object does not change means then we can say that that object are at rest. So in everyday life, we see some object at rest and others in motion. So birds fly, fish swim, blood flows through the veins and arteries and the core. These are the example for motion. And atoms, molecules, planets, stars and galaxies are all in motion. Look at this image. This is atom. In this atom, the electrons are in motion. If you take a solar system, here the planets are in motion. So these are the example for motion. There are the situations where the motion is inferred through indirect evidence. For example, we infer the motion of the air by observing the movement of dust and the movement of leaves and branches of trees. How you can say that the air is in motion? When you are observing the movement of a dust, the movement of a leaves and branches of a trees, these are due to the motion of the air. So we can say that the air is in motion. And what causes the phenomenon of sunrise, sunset and changing of seasons? Is it due to the motion of the earth? Yes. If it is true means, why don't we directly preserve the motion of the earth? Why we cannot see the motion of the earth directly? An object may appear to moving for one person and stationary for some other. Or you understand what is the meaning of this? An object may appear to be moving for one person and stationary for some other. For example, see here. Here the passengers are in moving bus. When they look at the trees on the roadside, the tree or appear to be moving backward. And the person standing near the roadside, the tree appear to be rest. So the object may appear to be moving for one person and stationary for some other. Here the trees appear to be moving for passengers in moving bus and the tree is rest for who is standing near the roadside at rest. So according to the person, the person's position, the object may appear to be moving or rest. So, what do these observations indicate? Most motions are complex. Some object may move in a straight line. See here the object are move in a straight line. When the object are move in a straight line, we can say that that is a straight line motion or rectilinear motion. And others may take a circular path. See here the object are in a circular motion. Some may be vibrate and some may be rotate. See here earth is rotate about their own axis. So these are the different type of motions occurring in the nature. When the object are in a straight line, then the motion is called rectilinear motion. When the object are move in a circular path, then this motion is called circulatory motion. When the object are vibrate to and fro or up and down, then this motion is called vibratory motion. When the object or rotate about their own axis, then this motion is called rotational motion. There may be a situation involving a combination of these. Look at this example. Here, the passengers are moving in a straight line. So, one motion is a rectilinear motion. Here, the wheel of the bicycle is rotating. So here the two type of motions are occurring in a single case. One is a rectilinear motion and another one is a rotatory motion. So we shall discuss the way of describing some other motions. The first one, for describing motion, we have to know what is meant by position, reference point or origin, distance, displacement, vector and scalar quantity. So we need to know what is meant by position, a reference point, distance, displacement, vector and scalar quantity for describing a motion. First, what is meant by position of object? We describe the location of an object by specifying a reference point. Let us understand by an example. Let us assume this is a school in a village. It is a 2 kilometer north of the railway station. So now we can say the position of the school according to railway station. How you say that? The school is placed in 2 kilometer north of the railway station. So here I represent the position of the school, a reference point to railway station. So in this example, railway station is a reference point. So describing the position of the object, we need to specify a reference point called the origin. So this reference point is called as a origin. This reference point is needed to specify the position of the object. Without a reference point or origin, we cannot specify the location of an object. So here the railway station is the reference point and school is the location of an object. So from this we can define the position of the object. The location of an object with respect to a particular point is known as the position of the object. The particular point about which the position of the object is defined is called reference point or origin. The next, motion along a straight line. The simplest type of motion is the along a straight line motion. So from this straight line motion, we can define what is meant by distance and a displacement. The distance is represented by the letter small letter d. That means how far an object travels. And it does not depends on direction. The definition of distance is how far an object travels, and also it does not depend on its direction. Imagine an ant traveling along a ruler. Look here, this is a ruler, this is an ant. Here the ant is traveling along a ruler. So what distance did the ant travel? This is the initial position and this is the final position. So the ant traveled 3 centimeter. So d equal to 3 centimeter. So the distance equal to 3 centimeter. The distance is nothing but how far an object travel. Here the ant travel only 3 centimeter. The next one, how I say that distance does not depend on direction. Here's our intrepid ant explorer again. See here. Now the ant travel from 3 to 0. So how much distance it traveled? Now what distance did the ant travel? D equal to 3 centimeter. So here the ant travel 3 to 0. So again 3 centimeter. So from this we can say that distance does not depend on direction. In the first case the ant travel in this direction. In second case the ant travel in this direction. So from this we can say that the distance does not depend on the direction. Here I just say the distance only. I did not mention the direction. So does his direction change the answer? In the first case the ant traveled from 0 to 3. In a second case the ant traveled 3 to 0. So does his direction change the answer? No. In a first case also the distance equal to 3 centimeter. In second case also the d equal to 3 centimeter. So from this we can say that the distance does not depend on the direction. Distance does not depend on direction. Let us follow the ant again. Yes. How much distance that ant traveled? What distance did the ant walk this time? D equal to 7 centimeter. How? From 0 to 5, 5 and 5 to 3, 2 centimeter. So totally the ant traveled 7 centimeter. What distance did the ant walk this time? Ant walk 7 centimeter. So it does not depend on the direction because the ant travel in this direction, then again it change their direction. So according to the direction, the distance value does not change. Then what is meant by displacement? The displacement is nothing but a difference between an object final position and its starting position. The difference means you have to subtract. How you can subtract? From the final position to initial position. It does depend on direction. So displacement depends on direction. Displacement equal to final position minus initial position. Delta D equal to D final minus D initial. In order to define displacement, we need direction. Example of direction, the direction may be positive direction or negative direction, or north, south, east, west, angles. Example of distance. Now we are going to see what is the difference between distance and a displacement. Example of distance. The ant walked 3 centimeter. The example of displacement. The ant walked 3 centimeter east. An object distance traveled and its displacement are always an object distance traveled and its displacement are not always the same. I will explain you. Let's revisit our ant and this time we will find his displacement. See, here the ant traveled from 0 to 3. So distance equal to 3 centimeter. What is the displacement? Displacement equal to plus 3 centimeter because the displacement need direction. So this is a positive direction, this is a negative direction. So here I written plus 3 centimeter. The positive gives the ant a ant direction. Here the positive symbol gives the ant direction. Find the ant's displacement again. Remember, displacement has direction. Now the ant travel from 3 to 0. So what is the distance? Distance equal to 3 centimeter, but displacement equal to minus 3 centimeter. Here the minus sign represent direction. Find the distance and displacement of the ant. Now we are going to find the distance and displacement of the ant. See, the ant travel 0 to 5, then 5 to 3. The distance 7 centimeter. How? 5 again here. So 5 plus 2 equal to 7 centimeter. It does not depends on the direction. So what is the displacement? Displacement equal to plus 3 centimeter. How? Because you know that the initial position 0, the final position 3, the final position direction, the initial position direction is the initial position to final position. We have to subtract the initial position to final position, the final position to initial position. The final position is 3, the initial position is 0. So 3 minus 0 equal to 3. So plus 3. The displacement equal to plus 3 centimeter. Are you understand how I find the displacement? See here, the initial starting position of the ant is 0. The final position is 3. Normally we know the formula of the displacement. The final position minus initial position. Here the final position is 3. So 3 minus the initial position of the ant is 0. So 3 minus 0, 3. So the displacement is plus 3 centimeter. The displacement versus the distance. An athlete runs around a track that is 100 meters long 3 times, then stop. What is the athlete distance and displacement? See, here the athlete start around a track at 3 times. The track is 100 meter. So what is the distance? The distance equal to 300 meter because 3 times here around a track. What is the displacement? The displacement equal to 0. Why? Because the starting position of the athlete is here and the ending position also here. So final position minus initial position is the same. So here the displacement is 0 meter. Why? Because the starting and initial position of the athlete is same. So the displacement value get 0. To describe a distance, we need to specify only the numerical value and not the direction of motion. The distance covered by the object is 95 kilometer means here the numerical value of a physical quantity is a magnitude. So to describe a distance, we need to specify only the numerical value. You need not you need not to mention the direction. Just you have to write 95 kilometer. Here the 95 is the magnitude and kilometer is the unit. And there are the two quantities to represent the physical quantity. One is a scalar quantity and vector quantity. The physical quantities which we can associate only magnitude, then these are called scalar quantity. And the physical quantities associated with the magnitude as well as direction means then this quantities are called vector quantity. See here 95 kilometer north. So here 95 is the magnitude, kilometer is the unit, and north is the direction. So the physical quantity contain magnitude means then we can say that these quantities are called a scalar quantity. Along with the magnitude, it contains a direction means this that is a vector quantity. So from this we can say the definition of distance. The distance traveled by a body is the actual length of the path covered by it, irrespective of the direction in which the body travels. The quantity, it is a scalar quantity. Why? It contains only the magnitude. The SI unit of distance is meter. We can measure the distance only by the meter. And displacement, the shortest distance measured from the initial to the final position of an object is known as the displacement. It is a vector quantity because it contains a direction. The SI unit of displacement also meter. Now, what is the difference between the distance and the displacement? See, here distance and displacement. Here I took one ball. I mentioned A, B, C. When the ball is at rest, the distance also 0, displacement also 0. When ball move from A to B, the distance is 5. The displacement also 5 because the initial position 0, final position 5. So 5 minus 0, 5. The next, a ball move from A to C. A to C means the total distance 10. The displacement also 10. Ball move from A to C, then C to B. First, it moves from A to C 10 and C to B 5, totally 15. So what is the displacement? Here the initial position 0, the final position 5. So 5 minus 0, 5. The displacement is 5. The next, a ball move from A to C, then C to A. In this case, the first ball move from A to C, so total distance 10. Then again C to A, again 10 kilometers. So distance equal to 20. And displacement, the initial and final position is the same. It travel A to A. So the displacement is 0. So from this we can say that displacement of moving object can never be greater than the distance. So see in all the cases, it never be greater than the distance. So we can write displacement by distance is always lesser than the 1. The next one, if a body moves along a straight line, then distance and displacement will be equal. When the body moves in a straight line, the distance and displacement are in same value and are equal. The magnitude of the displacement for a course of motion may be 0, but corresponding distance covered is not 0. Now sometimes the displacement and sometimes the displacement may be 0, but distance never be 0. See the last case. In the last case, the distance is 20, but the displacement is 0. And the displacement of the object can be positive, negative, or 0. The displacement value take positive value or negative value and 0 value. The next one, odometer. What is meant by odometer? How it connect this topic? If you take in automobiles, this odometer are fitted in the dashboard. It is used to measure the distance, and it is used to measure the distance and also displacement. See here, in automobiles are fitted with a device that shows the distance travel. Such device is called odometer. A car is driven from Bhubaneswar to New Delhi. The difference between the final reading and the initial reading of the odometer is 1850 km. So find the magnitude of the displacement between Bhubaneswar and New Delhi by using the road map of India. So here the odometer is nothing but it is the device, it is used to measure the distance traveled by the vehicle. And the next one, what is meant by uniform and non-uniform motion? A body covers equal distance in equal interval of time, then it's said to be in uniform motion. And body covers unequal distance in equal interval of time means then the body is said to be non-uniform motion. I will explain you, listen. See here, this is a time and this is object A and this is object B. When that see the time interval 9:30 to 9:45, the time interval is 15 minutes. The same as 9:45 to 10 o'clock, the time interval is 15 minutes. 10 to 10:15, the time interval is 15 minutes. So the time interval is same. And if you take the object A traveled by the distance 9:30 a.m. 10, 9:45 a.m. 20, 10 o'clock 30. So here the difference is a 10 meter from 9:30 to 9:40, 9:45. The same as 9:45 to 10 also 10 difference. So here the object cover equal distance in equal interval of time. Then the body is said to be in uniform motion. Maybe the object cover unequal distance. See here. Here the difference is 7 and here the difference is 4. Here the difference is 12. So, but the time interval is same. If maybe the body covers unequal distance in equal interval of time means, then we can say that the object are in non-uniform motion. Now you can understood the definition. A body covers equal distance in equal interval of time, then it's said to be in uniform motion. If maybe the body covers unequal distance in equal interval of time means, then it's said to be in non-uniform motion. And I hope you understood what is meant by motion and what is meant by rest, how to define the position of the object, and what is meant by reference point or origin, distance, displacement, and uniform motion and non-uniform motion. What is the difference between the distance and the displacement? So these are the homework questions. You have to do it. The first question, this is the first problem. I given the 5 problems. This is a problem number 2. This is a problem number 3. This is a 4 and 5. And thank you for watching.